Hey everybody, Jay at Backyard in Boulder. This video is for you if you want to have fun with your Raspberry Pi and like me, you're not an engineer or a great coder. I'll show you how I used off-the-shelf AI without any additional hardware, running on my Raspberry Pi 5 with 8 gig of RAM to trigger nature videos taken with the Raspberry Pi Camera 3 module. I'll also talk about how to use Google Gemini as a coding and debugging partner, which is a huge accelerator for me, letting me concentrate on my ideas and not on becoming a Python expert. I have links to a lot of stuff in the notes, including my code and the Gemini prompts I used, and some of the YouTube creators who inspired me. So let's get to it. Okay, for this project, I wanted to trigger video using real-time object detection using the YOLO framework from Ultralytics. They have instructions for installation, and Gemini can also help. I installed it in a virtual environment, asked Gemini about it. In the videos that inspired me to try this, they were using an AI accelerator top, but I tried it without that and it worked. So for small projects like this, you probably don't need to splash for that hardware. Now, with no training, the YOLO model is brilliant at recognizing people. But squirrels, my object of interest, were recognized as a bear, a cat, sometimes a dog, a bird, but it did this reliably, so you see those animals listed in my code there on line 13 along with people and a couple other animals. You can also see in the configuration section from lines 13 to 18 some of the other parameters you can experiment with, like the detection interval, which is how often you take a still image, 5 seconds here, the video duration, and the cooldown period, which is the time to wait after taking a video. Other notable things, you can see on line 23, I'm using the model YOLO V8N.pt. The N stands for nano, which means it's suitable for devices like a Raspberry Pi. Line 36 shows the video resolution, which will affect your storage, so test that out in your environment. I have a 256 gig SD card, but again, check out how that works on your setup. Also notice line 33 that the still image that triggers the video capture is 640 by 480. That's what the YOLO model recognizes to trigger the video. That seems to be a good size for both the accuracy and working well without the extra hardware. And don't worry, this code is downloadable in the notes section and there are comments in the code. To run this Python code, I connect to my Pi from my PC using SSH. If you're not familiar with SSH, Gemini can walk you through how to set that up. Note that you need the IP address of your Pi, which can change on a Wi-Fi network each time you start it up. So I set my Pi to email me its IP address whenever it starts up. Again, Gemini can help there. You could also just have it run the Python program on startup, but I find this difficult when I'm using the Pi for multiple projects. So the SSH command is run from your PC as shown here and connects to your Pi. Here I'm connected to JSON Pi 5 as you can see to the left of the cursor area. I then change to the project directory called YOLO prod and I activate the virtual environment where I installed Ultralytics. You can now see YOLO prod, the virtual environment, to the far left of the cursor. On my system, I run Python programs by typing Python 3, the name of the Python file, and then an ampersand to run the program in the background. When you use ampersand like this, you need to keep this terminal window open. If you close it, the Python program will stop. Since my Pi is in the backyard while I'm using this program, I keep this window open to check if I'm getting new videos and to check the temperature of the Pi, as you'll see in a moment. You can use a command called nohup, N-O-H-U-P, if you want to be able to close this window. Ask Gemini about that. Alright, so when I hit return to run this command, you see 43837 on the command line. That's a process number which I could use to stop this process using the kill command, but I'll stop it a different way later. After a couple seconds, you see that feedback there that the camera has started and it's ready for object detection. I'll stick my face in front of the camera to start recording some video so that you see that feedback on the screen. What it will say is that it's recording video and audio. I did experiment with audio, didn't get it to work. I just haven't changed that print statement, but I will before you can download it. So I'm going to show you the shell script that I used here in a second to check the temperature of the Pi. I also have the temperature mailed to me every hour. What you'll see here is that it's running, the Pi is running at about 55 Celsius. That's at my desk. In my backyard, it would get as high as 65. The desired operating temperature of a Pi is between 0 and 80 Celsius, so that's why I was keeping an eye on that. Alright, so that's pretty much everything. Hope you got what you needed to get started. I'd love to hear from you in the comments. If you found this useful, let me know. Please like and subscribe. A couple of videos I'm thinking about doing in the future. One's a little bit more of a deep dive on the creation of the housing for the camera and the Pi. Also thinking about covering how I trained a model specifically for squirrels. So let me know what you might like there. All right, thanks, and we'll see you next time.